Since its discovery, the interstellar visitor 3I Atlas has posed a profound challenge to modern astronomy, not because it is mysterious, but because its behavior does not conform to the physical framework through which we interpret comets and small bodies. The wide range of anomalies exhibited by this object along its trajectory through our solar system demonstrates that we are not dealing with a single irregularity. Rather, we are confronted with a coherent set of observations, photometric, dynamical, morphological, and plasma-related, all pointing in the same direction. This object does not behave as a classical comet. In this chapter, we present a unified and entirely natural physical model in which 3I Atlas is described as a carbon-rich body with conductive properties, whose activity is governed not by the sublimation of ice, but by sustained electrodynamic coupling with the dominant electromagnetic fields of the solar system and the heliosphere. Part 1. The observations. What was actually measured? Let us begin with the data. Along its trajectory, 3I Atlas exhibits an unusually stable brightness. There are no outbursts and no sharp declines, and its photometric behavior does not follow simple power law scaling with heliocentric distance. At the same time, a persistent non-gravitational acceleration is measured, with three clearly resolved components, A1, A2, and A3, acting over several months and decaying gradually. However, the most striking feature lies in the tail morphology. 3I Atlas displays a short, narrow dust tail, a reportedly collimated ion tail, and, most notably, a stable anti-tail directed toward the Sun, maintained over months. This anti-tail remains narrow, well-defined, and non-dispersive, both before and after perihelion. In addition, anomalous negative polarization has been measured, plasma signatures have been detected, and an extended X-ray halo has been observed, indicating active interaction with the solar wind. Spectroscopic measurements performed early in its trajectory revealed an anomalous nickel-to-iron ratio, with nickel exceeding iron, as well as an anomalous carbon-to-water ratio, in which carbon is dominant by approximately 8:1, according to official reports. These are not incidental details. They constitute hard physical constraints that cannot be explained by any model built from a collection of isolated anomalies. Part 2. Why the classical cometary model fails. The classical cometary model is based on the sublimation of volatiles. Heating leads to gas release. Gas entrains dust, and a tail is formed. Here, that framework collapses, point by point. The anti-tail is directed toward the Sun, contrary to expectations from radiation pressure. It remains collimated over hundreds of thousands of kilometers, whereas ballistic ejection should rapidly disperse. Activity persists even as illumination conditions change, with no clear dependence on day-night cycles on the surface. There are no strong signatures of water or other volatiles, as would be expected from an ice-dust body after perihelion. There is no classical dust coma. Instead, a vast halo envelops the object and, according to observations, moves with it while preserving structure. The non-gravitational acceleration has been measured continuously since mid-October. No known comet has exhibited such acceleration over so extended a period. Even highly active comets, such as Hale-Bopp or 67P, show non-gravitational acceleration that is neither stable nor long-lived, and is always coupled to declining activity, changing geometry, or rotational effects. Even softened models, coarse dust, asymmetric outgassing, or fragmentation, fail to explain the stability, collimation, and sustained acceleration without requiring the body itself to disintegrate. The conclusion is clear. This is not a localized failure, but a breakdown of the entire classical cometary framework for this object. If we invoke Occam's razor, classical Comet models fail outright, as they require 6 or 7 independent, unrelated assumptions to account for the observations. Part 3. A paradigm shift. Not emission, but coupling. Not ice and dust, but conductivity. To understand 3I Atlas, we must change our perspective. Instead of viewing it as a body that ejects material, we consider it a conductive object engaged in sustained electrodynamic coupling with its environment. 3I Atlas as a field-coupled body. In the proposed model, 3I Atlas is a carbon-rich body with conductive properties moving through the dominant electromagnetic fields present along its trajectory. This motion generates charge separation, induced currents, and an extended electric sheath that is not confined to the surface. The observed activity, the tails, the anti-tail, and the acceleration, does not originate from material expelled from the body, but from the interface between the body and the surrounding field. As a result, direction is dictated by field topology, collimation is preserved, and activity remains stable even as geometry changes. The space through which 3I Atlas moves is not empty. It is governed by the solar wind, heliospheric plasma, and electromagnetic fields driven by solar activity. It is crucial to note that after perihelion, during November and early December, the Sun was near solar maximum, a period of intensified solar activity, dense solar wind, strong field fluctuations, and highly active plasma. This context is critical for understanding the intensity of the observed phenomena. Part 4. A physical analogy. Io and Jupiter. To understand electrodynamic coupling, no new physics is required. As illustrated in observations, the moon Io moves within Jupiter's dominant magnetic field. The result is not merely material emission, but an entire electrodynamic system. Plasma currents, flux tubes, and a direct connection between a small body and a massive field source. Io does not emit this system. It is coupled to it. The analogy to 3I Atlas lies not in scale, but in physical principle. Part 5. Non-gravitational acceleration. Without mass loss. Within this framework, non-gravitational acceleration arises from an effective electrodynamic force acting on a charged sheath coupled to the surrounding field, analogous to a Lorentz-type force. Indeed, in mid-September, a change in the direction of the anti-tail was observed. Lorentz dynamics predict that a shift in pole orientation alters the direction of the resulting force. There is no need for jets, no need for rocket-like thrust, and no need for significant mass loss. This naturally explains the gradual decay of A1, A2, and A3, the lack of direct correlation between brightness and acceleration, and the preservation of structural integrity. Part 6. Material, polarization, and chemistry. What the composition really tells us. When examining the chemical composition of 3I Atlas, the goal is not mineralogical classification. Here, composition serves as a functional indicator. It tells us how the body behaves physically within an active plasma environment. Specifically, it addresses whether the body is insulating or capable of sustaining induced currents and entering electrodynamic coupling. Nickel-iron ratio. Not metal, but function. The anomalous nickel-to-iron ratio is not a minor chemical detail. It indicates a non-random metallic composition. Nickel, unlike iron, maintains structural stability at high temperatures, supports charge separation, and is known as an efficient substrate for ordered carbon layer formation under high-energy conditions. In laboratory environments, nickel is used as a substrate for graphene growth. In interplanetary space, there is no need for deliberate graphene synthesis. A sufficiently energetic environment with sustained particle flux is enough. The plausible outcome is the formation of a conductive carbonaceous obal on a nickel-rich metallic framework. Carbon versus water, a shift in the activity regime. The elevated carbon-to-water ratio also carries functional significance. In classical comets, water mediates activity, sublimation is the engine, and activity declines with distance. Here, carbon dominates. Carbon in graphitic structures does not drive jets, does not form ballistic clouds, but supports conductivity and charge transport. This explains why the observed activity, lax outbursts, is not tightly correlated with brightness decay and is not governed solely by thermal heating. Negative polarization, a surface signature, not a cloud. The negative polarization measured in 3I atlas is difficult to reconcile with a volatile-rich coma. It is, however, consistent with conductive surfaces, carbonaceous layers, and structures where light polarization arises from interaction with a dense sheath rather than a diffuse cloud. This is a subtle but fundamental distinction. We are observing the response of organized matter, not random particle scattering. What are we actually identifying? When we combine an anomalous nickel-iron ratio, excess carbon relative to water, and non-classical polarization, a single coherent picture emerges. 3I atlas is not a thermally isolated body, but one with conductive properties, capable of sustained coupling with the Sun's dominant electromagnetic field. In other words, chemistry here informs both what the object may be made of and how it operates. Part 7. Formation Environment. A body like 3I atlas is not a product of a quiet protoplanetary disk, not because such disks are unsuitable, but because the required physics does not persist there over long timescales. In such disks, conditions approach equilibrium, radiation is relatively weak, and electromagnetic fields are not dominant. By contrast, the characteristics of 3I atlas point to formation in an environment where energy and fields are not disturbances. They are organizing agents. Stage 1. Raw material in a high-energy environment. In regions resembling the galactic center, such as the Sagittarius region and the surroundings of Sagittarius A ASC, electromagnetic radiation is intense, plasma density is high, carbon and transition metals are abundant, and many processes occur far from thermodynamic equilibrium. In such conditions, matter does not settle slowly, it organizes while flowing. Stage 2. Electrodynamic selection. In an active plasma medium, particles are not selected solely by mass, but by their response to fields. Grains rich in transition metals, particularly nickel, sustain induced currents, respond to fluctuating fields, and preferentially accumulate material. This is a natural selective mechanism. Not all dust survives, not all aggregates grow. Only grains capable of dynamic integration within the electromagnetic environment persist. Stage 3. Carbon organization on a metallic substrate. In a radiation and particle-rich environment, carbon remains available, is not immediately locked into ice, and can undergo structural organization. On nickel-rich metallic grains, carbon tends to form dense, ordered structures. This requires no assumption of intentional fabrication. It is a process well known in laboratory conditions, scaled up to cosmic dimensions. The result is a conductive carbonaceous shell integrated with a metallic framework. Stage 4. Formation of a functional body, not an ice fragment. The outcome is not a classical comet. It is a body that is relatively compact, electrically conductive, and systemically responsive to external fields. Such a body does not require ice to be active. Its activity arises from continuous interaction with its environment. Stage 5. detachment, and interstellar transport. In dynamic regions like the galactic center, gravitational interactions are frequent, plasma flows are unstable, and material redistribution is ongoing. At some point, a sufficiently organized body detaches from its formation environment, enters an interstellar trajectory, and begins a long journey through the galaxy. This is not a single dramatic event, but a natural statistical process. Why is this scenario plausible? Each stage is physically established, observed in other contexts, and requires no new laws of physics. What is unusual is the combination, not the conditions themselves. Thus, 3I Atlas is not an impossible anomaly, but a rare outcome of an environment where fields, plasma, and matter act together as a single organizing system. Part 8. Prediction and a critical test. The encounter with Jupiter. One of the central strengths of the proposed model is that it is not retrospective. It produces clear, testable predictions that do not arise naturally from the classical cometary framework. Primary prediction: continuous decay, not collapse. After perihelion, and in accordance with the gradual weakening of the Sun's dominant electromagnetic field, the model predicts smooth, continuous changes in activity, not abrupt shutdowns. Specifically, overall brightness should decline gradually and steadily, without sharp fluctuations or secondary outbursts. The anti-tail, as a direct manifestation of electrodynamic coupling, should contract gradually toward the dimensions observed before perihelion while preserving collimation. There is no switch-off, only a progressive weakening of interaction. Spectral signatures: what should not change. Even as activity declines, relative chemical composition should remain anomalous. Spectroscopy should continue to show elevated nickel-to-iron ratios relative to classical comets, anomalous carbon-to-water ratios. Absolute values may soften compared to perihelion measurements, but the pattern itself should persist. This is a critical distinction. In classical comets, declining activity alters observed composition. Here, it should not. Polarization: stability as a diagnostic. The anomalous polarization measured thus far is not a product of a dispersing gas cloud. Therefore, even as brightness fades, the polarization signature and its general characteristics should remain stable. This is a subtle but powerful test of a conductive, surface-dominated structure. Non-gravitational acceleration. Smooth decay. According to the model, non-gravitational acceleration is not driven by emission, and therefore should not vanish abruptly. Instead, it should decay smoothly, tracking the weakening coupling with the solar field. Any sudden jump or discontinuity would challenge the model. Secondary test: Jupiter as an alternative dominant field. Here lies the most critical prediction. Jupiter is the strongest dominant field source in the solar system outside the Sun itself. As 3I Atlas approaches the outer boundary of Jupiter's electromagnetic influence, near the edge of Jupiter's Hill sphere, where its influence overtakes that of the Sun, the model predicts the possibility of a mild reactivation of activity, even as heliocentric distance continues to increase. This is not due to sublimation, not heating, and not thermal processes of any kind. It is the result of renewed coupling to a new dominant field. What should be observed? If coupling to Jupiter occurs, the anti-tail may exhibit a directional bias not aligned with the Sun, but toward Jupiter. Tail structures may experience a mild, temporary enhancement. Brightness may show a gradual or even sharp increase. Non-gravitational acceleration may deviate slightly from monotonic decay, not as a jump, but as a change in slope. This signature does not exist within the classical cometary model. Conclusion: 3I Atlas does not violate the laws of physics. It simply reveals a physical regime that we are not accustomed to applying to small bodies. Yet this regime is well known and well studied at terrestrial scales. If this model is correct, interstellar objects may not be mere visitors, but carriers of material and environmental physics underrepresented in our solar system. And that may be the true contribution of 3I Atlas, not a mystery, but an expansion of how we understand the universe.